Within this long section on cumulative distribution functions, there have been 5 subtopics, and those subtopics have been percentiles, and then random variate generation, and then transformations. We're moving on to a 4th subtopic here, and this subtopic is using computer algebra systems, and the 2 most well-known computer algebra systems are Mathematica and Maple, to manipulate random variables. This is actually a homegrown William & Mary product known as APPL, and APPL stands for a probability programming language. And you will develop a love-hate relationship with APPL because it will solve some problems that will simply take your breath away. They are so complex and so difficult to do by hand. And then it will also fail on some very, very simple problems. So it'll mix up a little bit that way, but you'll get used to it, and hopefully you'll appreciate it for the difficult problems it can solve. So here's the example. 2 billiard balls are drawn with replacement from a bag containing 15 billiard balls, numbered 1, 2, 3, all the way up to 15. Let x be the sum of the 2 numbers. Find the probability that x is equal to 17. This is very much like a problem involving the rolling of 2 fair 15-sided die and finding the sum of the 2 numbers that come up. So not difficult to solve by hand, but we're going to use a couple APPL built-in functions, and the first one that's going to be used is uniform discrete RV, and that'll define the pulls here from the bag. Then there's another one called convolution, and this convolution routine adds random variables. And then there's a third one that's going to be used that's known as PDF. Now these functions were written by William & Mary students. 2 PhD students started this language, namely Andy Glenn and Diane Evans, and it has been added to quite a bit over the years by Billy Kaczynski, Keith Webb, Jeff Yang, and Matt Robinson is now working on converting APPL over to a Python base as opposed to the Maple base where it is right now. Well, here is the APPL code. It's just 2 lines of code. Here's the first line. You set x equal to the convolution, that will add the 2 random variables, of a uniform discrete random variable from 1 to 15, and another uniform discrete RV from 1 to 15. Those are the 2 draws of the billiard balls from the bag. That gets added up, and the distribution of x, of course, can run anywhere from 1 plus 1 is 2, all the way up to 15 plus 15 is 30. And then we ask, what is the PDF of x evaluated at 17? And in that case, the probability x is equal to 17 is the probability mass function of the sum at 17, and that turns out to be 14 divided by 225. This is not Monte Carlo. This is an exact solution, and it's done in APPL using Maple as a base language.